So this is just a continuation of what we discussed in class today. What we started talking about today was in combination reactions, how to predict a product. So in a combination reaction, as you know, you have two reactants that come together to form a single product. And so what we're looking at is, okay, we know that we have reactant A, reactant B. What product do they go on to form? Okay, so reactants are what are present at the beginning of reaction, products are what are present at the end. And we do this by using some of the tricks that we've already known for a while, right? So like I said in class, we need to be able to recognize the diatomics using the NIH trick, okay? We need to know that for groups numbers 1 through 3, that the charge is equal to the group number. We also need to know that for groups number 5 through 7, that the charge is equal to the group number minus 8, as Nancy corrected me for in class. Good job, Nancy. So as we look through on this, I'll do one example similar to what we did in class. So for example, say that I tell you that you have aluminum reacting with nitrogen. Okay, and I'm asking you what the final product is. I am not going to concern myself at all with this 2. It does not tell me that the final answer is ALN2. That is not the case. What I need to make sure that I do is that the overall charge is 0. That is what is important for predicting products. So Al, I know, is in group 3, so the charge on Al is going to be plus 3. I know that N is in group 5, so the overall charge on N is going to be minus 3. So I know that Al plus 3 minus 3 gives me that overall charge of 0, so I'm happy with it. So I know that the answer then is going to be ALN. Okay, if I look at another example, and I have, let's say I have Na plus O2. Okay, again, I'm not looking for just going to be able to put NaO2 because this diatomic really doesn't tell me. What again I'm looking to do is make sure the overall charge is 0. So Na is in group 1, so it has a charge of plus 1. We could write that in, that'd be great. Plus oxygen, which is in group 6, which has then a minus 2 charge. So when I look at this, I know, okay, you know what? I actually need another Na in order for that overall charge to be 0. So then what this gives me is Na2O. Now some of you, again, know from class are looking at this and are saying, oh, but law of conservation of mass, this really bothers me. That's where balancing equation comes in, and we'll do that in our next unit. At this point, though, what we're looking for is how to predict a product.